Hello, everyone. My name is Scott Bates. I'm going to be going over the Candy Compounds Lab for 8th grade science year 1 training. So before I start, this lab is located in Unit 3, Chemical Bonding, Reactions, and Energy in the A Plus campus. This is actually one of my more favorite labs just because it's very cheap. It discusses ionic and covalent bonds in a very fun way for the students, and they always seem to enjoy it. So this video is what's going to be about is pretty much slide 2. We're going to talk about the objectives and the Marzano strategies of the lab. Slide 3 talks about how this lab will look in the classroom with the work snippets from the worksheets and the materials and stuff like that. I know now that this is a COVID-19 world and this lab may have to be modified, but this is how it would have looked normally. So keep that in mind. Then slide 4 actually starts the directions of this activity and how you're going to earn your grade and credit for this activity for the 8th grade science year 1 training. So let's go ahead and get started. So the objectives. So this is again a very good lab for students to practice bonding with ionic and covalent bonds to see the difference. They really enjoy this lab. With this lab, I'm actually able to walk around the classroom, hear my students' conversation. It's always great conversation. Butt in when you need to, and it's just a really. I've always had great experience with this lab, and you can also modify it in many different ways. Now for the Marzano strategy, I put processing content. There's many other Marzano strategies that could be included here. It depends on how you do it in your classroom. You could have some movement in your classroom. Reluctant learners absolutely love this lab. Because again, the lab is called Candy Compounds, and you're playing with candy. I mean, you really can't beat that. So this is on slide 3. This is actually how the lab would look like in the classroom. So the materials you would need toothpicks, gumdrops, Ziploc bags. You would just already have the amount of gumdrops that each group would need in the Ziploc bags just to save time. Candy key, which is right here. There's about, I think, 6 per page. Each group would have that, and a student worksheet, which the student worksheet this is just a snippet from one of it. It's a full sheet with all the compounds. I believe there's 7 or 8 compounds that the students actually have to do. But this is what they would pretty much do. They're going to follow this table. So for instance, H2. So they would list the names of the atoms. So they'd put there's 2 and the number of each. There'd be 2 hydrogens there. The type of bond, they would have to know the difference between ionic and covalent bonds. You can actually intro that with this lab, or they already have some prior knowledge. So this would actually be a covalent bond. Then they would actually make their gumdrop model, and then they would also color that. And again, this is something that they love doing. They like to color, and they got to pick which normally I will sometimes let the students pick their own colors, and they actually could come get the gumdrops themselves. It just depends how you want to do it, but if you want hydrogen to be red gumdrops, then they would color that red. Or like I said, normally it'd be a little bit better if the teacher sets the key, but it just depends on the class, So they would make their gumdrop model and color this as well, and they love to make these little models, toothpicks with gumdrops in them. And then the dot structure, which they do struggle with the most, and I do make them do certain things depending if it's covalent and ionic, and I'm trying to do the same thing for y'all in this activity. So to get into the directions for this activity, this is all graded. You need to complete the pre-lab questions. There's 3 of them on slide 5, very easy questions. There's a few identification slides you have to drag and drop, and you do have to type a little bit. It's not that bad. And then the extend evaluate question. There's one question on slide 14 I would like for you to answer. So we're going to skip the pre-lab questions. I believe you can answer those. Now, I'm going to give you some tips on how to drag and drop on this, because it can be annoying if you don't know the tricks to do it. So I'm going to do a few examples for you. Oh, I accidentally left this filled in for you. But normally the first step, and again, that's fine that I left it, is you would need to look at the compound H2, and you need to type the number of each. Now, when you do this, if you press enter that will happen. And so I'm going to press backspace to reverse that. The reason that is on this activity, I do have it to where you can't click certain things. Like right here, you cannot click this, and you also can't click this. And that's just the only issue with this activity. But you can click where you need to, or you can just press the down arrow, and that won't happen. So you need to type the number of atoms of each. So you can say there are 2 hydrogen. And then you would also need to type in the type of bond, which is a covalent bond. I also provided the candy key from slide 4 right here at the top for you to reference, so you don't actually have to go back to that. Now I got some instructions right here, and as you can see, number 1, use the line for gumdrop section. So use that line for gumdrop section, which is right here, the gumdrop model. So use circles for covalent bonds. So if there is a covalent bond, which this is a covalent bond, I want you to use circles for that bond. And I actually did that for my students as well, because I want them to know that covalent is sharing. It's not the same thing as non-ionic bond. And then number 3, and this can be difficult with some of these more complicated ones, and I'll try to help you out with that, but use different colored dots for each element. So let me show you exactly some tips on how to do this. So to do the gumdrop, for this one, we need 2 hydrogen, which is 2 red gumdrops. So before you drag and drop anything, look for that little white cursor and see how my mouse changes to that. When that changes to that, that's when you can drag and drop. And it works really well with some of these things, but sometimes it doesn't pop up. So please be very careful by that, because it can annoy you sometimes. So I'm going to drag 2 gumdrops here very simply. And this is my little toothpick that I have. And there we go right there. That is a perfect gumdrop model. Now just imagine your students, putting gumdrops in toothpicks. I mean, they would love this lab, and they always do. And this is just the first one. It's very basic. So I made my gumdrop model. Now the dot structure. Now this is a covalent bond. So we do need 2 hydrogen. And even with my students, when they're struggling with the dot structure, I always ask, you may not know how to do the dot structure, but you do know which elements are present. There's 2 hydrogen. And so now this is actually where it's a little tricky, and I try to make this as best I can, but see how it goes to just the regular mouse cursor, then it goes to that white cursor. Wait for that before you click to drag. Again, I tried to make it as easy as possible, but it was not the easiest to do this. And again, you can grab multiple H's. And again, if you want to put the circles down first, it's up to you. Now I'm going to put these circles down. Because this is a covalent bond, we're going to put circles around each hydrogen. And I'm trying to make this perfect, but it ain't going to be perfect. And now we need to put the electrons, the valence electrons, just to show the bond. So for this, I want you to use different colored dots for each element. So for this one, and again, you can do it several different ways. But personally for this one, I would want to do, even though it is hydrogen, and it's the same element, you could use this one right here. But for this one, which it is so basic, I think it's the only one this actually happens on like this. I would probably try to use different colored dots just for this one, because I want to see, and your students want to see, you want to see as a teacher that this hydrogen's red electron and this hydrogen's black electron, they're sharing each other. And so they're able to be stable. Now, I think this is the only one where the colors are different, but normally I think for the rest of them, you can actually use different colored dots for each element. So let's do one more example. Or I'll actually do 2 more examples. So for number 2, this is sodium chloride in NaCl. And again, same thing. You would, 1 Na, 1 Cl. I'll let you do that. So this is actually a ionic bond. Very simple. And again, depending on how you want to do it. And I also recommend when you do this, if you press enter, that'll happen. So press backspace, and I would probably just put a comma and do 1 chlorine. Again, just how I have it set up, it's going to do that. 1 sodium, 1 chlorine. So for the gumdrop model, this is actually very simple. You just need to get 1 chlorine, which is orange. And you need to get 1 sodium. And I always do make my students write out the sodium for Na, sodium like that, because I'm trying to get them to not really memorize the periodic table, but they get more used to it. They recognize it more. And then I'm going to use my little toothpick, and we got this little bond right there. And also, just to let you know, another tip: when you're doing the bond, you can rotate this because as you know, atomic structures do have a angle on them sometimes. So wait for that black plus sign, and you can actually move it, and you can make it diagonal, or you can make it however you would like. So just keep that in mind for future problems. Now, the dot structure. Again, let's say our students don't know how to do this. The dot structure, I always tell them, you know what elements are there though. You know that sodium and chlorine are there. So again, this one's probably the hardest part of the whole lab. Make sure you have that little white cursor thing, sodium and chlorine. Now, each of these have only one valence electron, and this is an ionic bond. So it's not a covalent bond. We're not going to use a circle. So it's just going to be a simple thing like this. And this is a great way for them to see. And again, in the actual lab itself on the paper, I would usually make them use arrows to show that, they're not sharing stuff, but this is just a little bit easier way to do it. Just, covalent. I know if you put circles, it's covalent. And if it's not circles, I know it's an ionic bond. Now, I am going to skip to a little bit of a harder one just to show, and I'm not going to complete it. I will just show you a tip about it. So this is CO2, number 7. And real quick, this is going to be a covalent bond. And again, you can type covalent if you would like right here. That's fine. But you would make the gumdrop. And again, this actually does matter when you think about the students. So carbon is going to be purple. And then you got your oxygen, which is going to be yellow. They actually, and the thing is, and you actually see mistakes when students start doing this lab. Where they put the element is actually very important because they got to think about the actual structure of it as well. But the thing is, when they actually make the model in the lab itself, they don't actually fully see they can't see the valence electron sharing or anything in this gumdrop model. But when they actually draw it out, they actually see the point of the structure. And I've actually gone backwards before doing some of these. Now, I will give you a few tips on how to do this real quick. So obviously I'm not going to do the full thing for this one. So be very careful when you're clicking. Wait for that white cursor thing. So you got carbon, you got oxygen, and you got oxygen. And I would say probably separate them a little bit. And again, it doesn't have to be absolutely perfect because we know this is dragging and dropping and it's kind of hard to do. You got 3. Well, that didn't happen before. You got 3 circles. Again, wait for that white cursor. I'm being impatient myself and it's messing up. Try to get the circles. You do need to include all of the valence electrons. So we know that, for instance, oxygen has, 6 valence electrons normally. And so, I would, you could choose, okay, I want the oxygen to have red valence electrons. So you need to actually think about, this carbon is sharing all 4 of its valence electrons. So we know there's going to be 2 electrons here sharing, 2 electrons here sharing, but carbon also needs 8 electrons. So you need 4 electrons in between carbon and oxygen and 4 in between carbon and oxygen on this side. So the way I would do this one would be, I would do pick carbon, let it be, again, just wait for that white cursor. Don't get impatient like I'm doing. It doesn't have to be exactly in the circle. It's kind of hard to do. Try your best. So we got our carbon. And again, that's what happens. Be very careful on that. I'm trying to just click the dots, and it's kind of hard to do. But and again, you have to mess with it a little bit. But you got, and worst case scenario, you can actually delete this and grab another circle if you want to. But now we got to include the oxygen electrons. And again, you'd put those right beside it because they are all sharing. So carbon right here has 8 electrons. But now we still have 4, and we still need to do 4 valence electrons for oxygen. Now, this is what's really cool about this. The same as the toothpick. We're going to use red for oxygen. You can actually, and again, you could actually do it this way. So if you go up to this little thing right here, this little dot, you can actually rotate your electrons. And that's a little crooked, but you can make the valence electrons right there where oxygen's supposed to be, above and below. And again, you're gonna have to rotate. It could be annoying, but I promise you, this activity is not that bad once you start really getting used to it. But you can see where I'm going with here. And I want you to use like this rotation and these tips and completing the rest of them. Now, the last part is a simple extension question. So this lab is a very awesome lab, but it doesn't involve really any real life chemicals. So think about some real activity or lab that actually uses covalent autobonds. Would you pair this lab with? What lab would you do after this lab? Or would you do this lab, like a brief version of it? I mean, you can all refer to those gumdrops all the time. So anyway, think about all those things. Hopefully you get this. And like I said, tip, wait for that white cursor before you move things because it can be annoying. But I know you can do it. So anyway, thank you so much.